Welcome to day 24 of our Advanced Python Concepts series. Today we will be diving into decorators, a powerful feature in Python that allows you to modify the behavior of functions without changing their actual code. Let's get started. First, let's explore what decorators are. A decorator is a special type of function that allows us to add extra functionality to other functions. In simpler terms, it wraps a function and modifies its behavior without altering its core implementation. Decorators are widely used in Python for tasks such as logging, memoization, and even access control. Now let's look at the syntax of decorators. A decorator is itself a function that takes another function as an argument. Inside this function, we define another function, often called the wrapper function, which is the one that will call the original function. Finally, the decorator returns this wrapper function. Here we have a simple example where we decorate the display function. The decorator underscore function line applies the decorator to the display function, adding functionality before the original code is executed. So how exactly do decorators work? When a function is decorated, the original function is passed to the decorator. The decorator then wraps this function inside another function that can add extra behavior. This wrapper function is the one that's actually executed when you call the decorated function. The decorator essentially intercepts the function call, performs some actions, and then either proceeds with or modifies the function's output. Next, let's see how to create custom decorators. Here's a basic example. The simple underscore decorator function takes another function as input and wraps it with additional behavior. Before calling the original function, it prints a message, and after calling the function executes, after the function executes, it prints another message. The output of this decorator is before calling function followed by the function's output and then after calling function. This is the this is the power of decorators. You can add custom behavior around any function. Decorators can also accept arguments. This requires an additional layer of nesting because the decorator itself now needs to accept parameters. In this example, we define a decorator underscore with underscore args that takes a message as an argument and passes it to the wrapper function, which then prints the message before calling the original function. This gives us more flexibility and makes the decorator more powerful. Decorators have many practical use cases. For instance, they can be used for logging, where you log every time a function is called. They can also help with authorization, ensuring that users have the proper access rights before allowing function execution. Another common use is memoization, which caches the results of expensive function calls. And of course, timing functions. Decorators can help you measure how long a function takes to execute. Python comes with several built-in decorators that make our lives easier. The static method decorator is used to define a static method in a class. The class method decorator defines a class method which operates on the class itself rather than instances. Lastly, property is used to define methods that act like attributes, providing a neat way to access computed values. Now let's try a practice exercise, a time decorator. This decorator measures the execution time of a function. We use the time module to record the start and end times, and the decorator prints the time it took for the function to execute. Here we apply the timer decorator to a simple function, slow function, which pauses for 2 seconds before printing a message. This shows this shows you how to create a decorator for measuring performance. To wrap up, decorators are an essential feature in Python that allows you to modify or enhance functions without changing their original code. From logging and memoization to performance tracking, decorators are widely used in Python applications. I encourage you to practice creating your own decorators. Understanding decorators deeply will significantly improve your Python coding skills.